Today on Performance Talks, we continue with part 2 of our 3-part series with performance legend and debugger extraordinaire Bryan Cantrill. In today's episode, we'll dive deep and discuss when you should look to develop a system from first principles, how to fight complexity creep, and modern language improvements that help you along the way. Spoiler alert, it's Rust.
The advantage of building a system from first principles is, and this is kind of, a hardware equivalent of what you're talking about in terms of co-designing data and code, because to separate, and on the one hand, separating them obviously can have a lot of value, but creates a lot of complexity in the system. And how do you balance that, and how do you know where to go to first principles and where to just resign to downloading something off the internet
and calling it a day?
And I kind of think it depends on how well where that downloaded thing off the internet works pretty well. I think that can be satisfactory. There are not very many examples of that, I don't think, unfortunately.
I mean, I'll reach for Postgres all the time. If there's a need for a small relational database, got to be relational and it's got to be small.
If it's a small, if it's a small database and everyone's going to go home at 5 o'clock, Postgres is your database.
Yeah, and you know what? It's great for that, and it has a lot of advantages.
It does,
right?
And if it's cranking 24/7. And of much larger size, then if auto vacuuming hasn't ruined your life, it will. It's coming for you.
Right. Or when I see time series merged onto Postgres, it's no. She's not going to like that at all.
And when Postgres is an interesting example, because it's that is a technology that I was wow, this is good. If you talked to me in 2015, when was it? Where sometime before the great loss of innocence with respect to Postgres, when my databases were small and my auto vacuuming was just an implementation detail. But sometime in there, I was force-fed fruit from the tree of knowledge of good and evil, and like a foie gras goose. And now I can't see anything other than a system that operates so profoundly across purposes under load. And I mean, there are so many implicit cues in Postgres, and they are so deeply implicit that the people who build Postgres can't even explain where they are. Because look at replication. I don't know if you use replication or not, Postgres replication. Not to go on a rant.
I don't. I mean, if I got to a point where I was like, hey, we're going to need to replicate this and have a bunch of read things, that is literally the moment where I would be like, okay, is this the right tool for the job? Let's take 15 minutes and talk about it.
See, that's wisdom right there. That's wisdom. Because the way Postgres does it, it's an interesting object lesson, because Postgres is hey, you know what? What is replication? What is replication? What are we trying to do? We're trying to have, we've got a database that is the primary, we've got another database that's the secondary, and we want the secondary to more or less keep up with the primary. Well, we're going to log our intent over here on the primary, and then we're going to apply it. What if we just take these logs, ship them to the secondary, and apply the logs in the secondary? It's okay, well, yeah, that makes sense. And then actually, if we're going to do that, you know what that is? That's just crash recovery. That's what that is. Taking the logs and applying the logs to the database. Replication is really just an example of crash recovery. And that's where you're on the one hand, we are in the proximity of some of these very elegant observations about software, when this thing over here that you're trying to do that seems complicated is really just another example of this very simple thing. And we can elegantly do this much more complicated task in terms of this simple atom. On the other hand, it's also an example of total abstraction abuse, where actually the system is as complex as you thought it was. And by using the simple thing, you're actually just making the emergent behavior of the system that much more difficult to understand. And there's a huge gray area in there. And I been on both sides of that. And I would say that Postgres is like, I don't think this is a good decision in Postgres. Because why is it not a good decision? Because that crash recovery is single-threaded. The database is multi-threaded, multi-processed anyway, multiple threads of control. You've created a situation where the primary, when under sustained load, can do more work than the secondary can possibly keep up with, tautologically. And when we discover this, are we the first people to do this? Like, why? But as it turns out, like, this is just not something, and it's like, I don't blame them for not considering it necessarily. And you do get to the point where it's just like, okay, so should we just be using something? Are we using the wrong tool? I don't know.
But I mean, that's kind of the point, right? Is that you're supposed to get to these moments and say, are we using the wrong tool? And I think, I see this a lot.
Are we in the wrong boat? Yes, we're in the wrong boat. We're also in the middle of the Pacific. So like, I don't know. Yeah, you're in the wrong boat. There you go. It's a little bit clarified for you. You're in the wrong boat.
But I think, and again, maybe I'm just getting old. And as you get old, you get cranky. But like, there's a generation of engineering that has just a love of complexity and almost infrastructure porn that is literally the opposite value. Like, I would never ever like, it's like how many Kubernetes sharded podded systems and cores does Edgemesh run? It's like, I mean, if we're doing our fucking job right, we should be able to knock it out on like one. Like, Edgemesh can run on one machine. It has run on one machine. Shouldn't, but sometimes shit happens. And like, we're very glad that we can run the entire back end of the company on one 64 core machine. Because guess what? 64 cores is a shitload of cores.
Yeah, it's actually a lot of cores.
Yeah.
No, I agree with you. There is this, and I don't totally get it. I don't understand where it's coming from, and I don't know if it's generational or if it's a consequence of experience, because it's very hard to conflate those two, where one is convinced it's a generational issue, it's actually just an experience issue. I don't know, but I do see that this thing about throwing complexity at the problem, and it's so frequently, I don't understand how even people are able to do it, honestly. I don't, like, doesn't your head hurt not understanding what's going on here? But apparently not.
But maybe that's, I mean, I have always found it very, very, like, my breaking point has always been when I can no longer keep a system in my head.
Oh, God.
That's generally when I need to stop and find a partner, right? And it's like, okay, I can understand this piece of the system if you can understand this piece of the system. And like, I've worked in really large systems where I obviously can't understand the whole thing. But where that handoff was always very clear to me. And it would be like, okay, well, I'm in charge of all of this. You're in charge of all of that. And I've always felt like whenever I've jumped into OS development, I've always felt like the OS is kind of like that. Like you get into pieces of the OS, you're like, okay, I don't understand how, whatever, libumem works. But like, there is somebody who understands it, and it's understood very, very deeply. And here's that handoff point. And so is it complex? Yes, it's complex, but it's not complex for the sake of complexity.
Well, yeah, and importantly, the abstraction itself is simple, but the implementation is complicated, and it has spent just a lot of time being vetted. And I do think that's an important artifact of these systems. The other thing that I don't get is these systems that get thrown away so frequently, where these big systems get built and then thrown away. And I'm just like, don't we want to get systems right and then like never throw them away?
Yeah.
I mean, and this is like certainly this is the K disposition, right? Where it's like, actually, and part of, we do a lot of Rust at Oxide, and part of what I love about Rust and continue to love about Rust is it shifts that cognitive load from the poor SAP in production, I guess the AI ops, Siri dealing with this thing in production, but it shifts that cognitive load back onto the developer. So it's the developer that needs to think about these issues. And there are times when Rust can feel really pedantic, and you have to remind yourself that, like, actually, Rust, you're driving me crazy right now, but you're raising a good point. You're not wrong. You're not wrong. And yes, I actually need to, make this particular, like go get a timestamp in Rust, for example. Rust is like, okay, oh, you want a timestamp? Okay, well, first of all, let's talk about time. Let's have a conversation about what does time even mean? And it's like, first, like, if you programmer want me, Rust, to give you a timestamp, I am going to force you to tell me that you want a timestamp from the beginning of the epoch. It's like, oh, what's the epoch? If you don't know what the epoch is, you're not ready for this. It's like, whereas other programming languages would have you be like, here's a number. It's like, oh no, I could give you a number. I could give you a number. But then you know what? You would do the wrong thing with it. And so Rust forces you to be very explicit in a way that I actually like, and does kind of force but it's like when you build software that way, you want it to be permanent. It's like, hey, this software is now correct. Let's stop rewriting it. And I think that my indefinite desire for the future is that we begin to write more and more correct components. Like, your libum example is a correct component. We don't need to rewrite it. Let's get more and more correct components, and then allow us to get the best of both worlds, where I'm using it. Yes, I'm not having to build the entire system myself, but I'm able to use a component that itself is well understood, that itself has been carefully designed, that itself has the scars of battle on it.
And I think that, it's interesting. That's why you like Rust. Well, I like Rust. And I think like is a strong word. I'm dating Rust casually. We're not engaged or anything, but we've gone on quite a few dates. And what I like is that using another I actually wish it was harder to use C in Rust. Ideally, I would like it to be impossible, just for a few more years. Like, unsafe is a good way to start. Let's call it what it is. But like, there's something very hygienic and complexity destroying when a language starts with an inability to use other things. It almost has to start from a place of purity. It's like, hey, we're going to need to build our own B tree. We're going to need to build our own, file layout. We're going to need to build our own mmap implementation.
But okay, so counterpoint though, that was Go, and they reinvented a lot of it badly.
Garbage in, garbage out. I think, and again, I think this is kind of like, when do you reach correctly? Yeah. Like, step one, let's embed the system table in the language.
Right.
Okay. Take 2 steps backwards, please.
Right, exactly.
That's the line, and I want you on this side of it. It's like, how do you feel about stacks? I feel like they should be upside down. It's like, why? It's like, why not?
Because that's the way Plan 9 intended. It's like, okay,
right,
yeah. So no, I'm with you, and I do. But I also the fact that Rust, to be able to cleanly operate with C, means it can cleanly operate with the machine itself, and that's what I actually love about Rust. Is that, unlike virtually any other high-level language, and certainly no other language that gives the kind of guarantees that Rust gives, you can actually control what is generated and runs on the machine. So we're using Rust for firmware. Among lots of other places, but we're doing lots and lots and lots of embedded Rust. And having now done this for whatever it's been, 6 months, I can't even think about using C for firmware. You're just like, oh my God.
Wow. Which is interesting, because you're very much a child of C.
I am very much a child of C, and I would, there's a Rubicon you cross with Rust, where once you've crossed that Rubicon, C now is all undefined behavior. Like it used to be with C, I didn't fixate on the undefined behavior because I knew where to avoid. I would focus on the road, right, which is the defined behavior. But once you've done enough Rust, you realize that, like, well, you should stay focused on the road because there are no guardrails. You're on a mountain pass. You're going 95 miles an hour, and it's raining. And which may explain why you've ended up in the ravine so frequently. It's like, yeah, that does explain it.
So let me ask you a question. So you've been programming in C professionally for more than 2 decades.
That's right.
Right? I've been programming in C professionally for more than 2 decades. And by the way, I do not trust C. I do not trust my C. I've tried a bunch of different languages over the years, but I've never jumped. Like if you put me in a Mission Impossible situation where like I had to save the world and I had to pick a language, I mean, obviously I would pick K if that was an option, but it's probably not going to be an option. So I would pick C. You're saying you're at the point where your Mission Impossible language is Rust?
Absolutely, yeah.
Wow.
Yeah, no.
Have you ever had that? Because you did have this brief moment where you went over into JavaScript land and did a bunch of mushrooms and kind of disappeared for a few years.
I didn't. I thought this was going to be kind of a safe space. I didn't realize that we were going to talk about. That was JavaScript. Yeah,
but no, I mean,
it's true. It's true.
Is this the first time that you've actually sat down a book and been like, okay, this is going to be my language for the next 10 years?
It is. So, and I would say that, kind of the progression there is, there was the regrettable experiment with JavaScript. There was, I think, also the one thing I would phrase in my defense is I didn't really appreciate the power of a functional language before JavaScript. That just sounds like a terrible thing to say. That sounds like such an idiotic thing to say. But it is like, it's the God's honest truth, but it just sounds moronic. But it's true that I really did not appreciate the power of a closure before JavaScript. And, we can reflect on my poor education or on the decline of civilization. I'm not even sure, I'm sure like Rich Hickey would have like a seizure and begin to see, would begin to black out knowing that I'm sorry. I'm sorry for what it is, but it's true. So I think that was the kind of the power of JavaScript that I appreciated. And I think that, in anything, like you think like, okay, maybe the kids are right. Maybe maybe I've been too uptight about things like types. And let's try it this way. And definitely went down that path. Tried to moderate the kids a little bit. I mean, and I hate to say children sounds so pejorative, but as a parent, I get to be, ageist in that regard. But I tried to find ways to make writing JavaScript more robust. And those did not succeed because it's not designed to write robust systems, sadly. Even though I thought it could be used to write robust systems, at every possible juncture, JavaScript has chosen to make it easier for more people to write the system and more difficult for people to write robust systems. Over and over and over again, it's made that case.
See, we happen to have an interesting company in that we have the vast majority of our software that actually executes client-side in the browser, which is clearly written in JavaScript.
Right.
And WebAssembly. So there is actually Rust in our house, but only to generate WASM.
And one can write rigorous JavaScript. It's just, it is very hard. The language does not help you at all in doing it, and you've got to do a lot of tooling on your own.
You really do.
And I am the only person doing this. Like, I am. I mean, it just feels like you are fighting the prevailing culture at every step. That's how we felt, anyway.
Yeah, I think one of the things that we've found interesting really recently is that, in web performance, there's kind of this big focus on like, how long does it take to download? You want to make your payload size as small as possible, which, like, of course, that makes total sense. If you want to make something faster, move less data over shorter distances, you're using a more efficient protocol. That's it. That's all you got to do. But JavaScript is kind of interesting in that what we've found is that the parsing overhead dramatically outweighs the download time.
Right. Yeah.
And what you really want to do is you really want to get something as simple as possible, like really, really tight, really, really simple. And like just recently I had to do something with one of our engineers, and I don't write JavaScript, and there are a lot of reasons why that's true. But one of the things I did was just kind of abuse a handful of the operators. I was like, oh, it's like this turning out. Like, I understand how this thing's working, and like we're just going to use it to do this other thing. And that's actually going to save 25 lines of code. And it's going to save 4 branches, and like this thing is going to parse much quicker. And so what's interesting is to write high performance JavaScript, you end up with code that is completely unreadable by most people.
Well, and so and this is the great fallacy, and this is true of Java as well, that anyone writing high performance Java had to reverse engineer the garbage collector.
Yes.
And
which was always what we did, which is why like my complexity, like my Postgres auto vacuum is the JVM. Yeah. I will never run a production system on the JVM ever again in the rest of my life. Because it's just too hard to debug.
I will take that vow. I will join you in that, because no, I agree with you. And it was much more of a glancing blow with respect to JVM, but trying to get a big Cassandra cluster to perform, and you had these latency outliers that were just unresolvable in the end. That were very, very, very frustrating. And it's like, why are we writing a database in a GC language? I don't get it. And every sophisticated Java system ends up having to reverse engineer the garbage collector. It's like, well, then what's the point of a garbage collector if the point of a garbage collector was to make it so you didn't have to think about memory, but now you have to think about this much more complicated thing, which is a garbage collector, and you're constantly like accommodating some family member with a substance abuse problem. People are constantly trying to like cover up for this thing and be like, oh no, like no, if we wanted the garbage collector to see this, so it'll pick it up. So it's like we're gonna do all these tricks so it will see that it's garbage quickly. It's like, what are we doing here? And it's one of these moments you get to kind of question these decisions about like, why are we? And part of what I do love about Rust is like, let's see if we can give you let's get you off of some of the dangers of C. Let's give you some of the same ability to control the machine. But let's do it in a way where you can reason about how memory is being used. And in fact, not only can you reason about how memory is going to be used, okay, you're going to have to reason about how memory is being used.
Right.
Because that's what Rust really forces up in your grill. It's like, and the ownership model really forces you to think about this, which can be off-putting. But on the other hand, you see exactly why it's trying to do what it does. And then the artifact itself is very high performing. And it's like, it just feels like that is a very positive development in systems development.
Tune in next week for the conclusion of our Cantrillian trilogy.